All right, this is topic 24, constant and power rule. So if I were to ask you, what is the derivative of f of x, right? If the f of x is a constant, it's the same thing as if I were to ask you, what is the slope of this line, all right? So the constant rule says that the derivative of any constant is always 0. And again, that goes back to this. If you have f of x is equal to a constant, the slope here is 0 always, all right? So it doesn't matter what the constant is, that's always going to be 0 for the derivative, all right? Now, just to get familiar with the notation, remember if you have d over dx, this right here means the derivative with respect to x. Right, so the derivative with respect to s of some function to some power like this, all right? So the power rule, all right, that we're going to use here tells you that the derivative of anything like that would be n x to the power of n minus 1. So just to make sure we understand one another, is if you have a power, you're going to bring the power to the front and multiply times that coefficient, which is what we have here. So we brought that in. And then we're going to subtract 1 from the power. For our example, if I ask you what is the derivative, all right, I'm looking for the derivative of this right here, what you would do is you would bring this 2 in front here and then multiply it times that other 2. All right, so this right here would be 4x. All right, and then when I subtract 1 from this power, I would get 4x to the first power, or just 4x. All right, on the next one, all right, if I ask you for the derivative of 3x, okay, I would have, this is x to the 1 power. I would multiply that 1 times that 3, and I still get a 3, all right? And if I subtract 1 from here, if I subtract 1 from this power, I would have x to the 0 power, and anything to the 0 power would be 1. Okay, so if you don't understand, this is what I mean, all right? So if I've already just taken the derivative of 3 to the x, that would be this, which gives you that, which you end up with that, all right? So, but in general, if all you have is an x and you're taking the derivative, you end up with the coefficient in front of it, okay? And the derivative of negative 6 is 0, so I'm not even going to bother writing plus 0 here. All right, on the next one, example 2, if we want to use the power rule, okay, we can't have it as a fraction like this, all right? So we got to convert this into a negative exponent like this, and then now we can do the power rule. So again, one more time, you grab this negative 2, you put this in front, so f prime of x is equal to negative 2 x, and then you subtract 1 from here. Okay? And again, we don't want to leave any negative exponents. Alright, so we're going to have, let's see, negative 2 over x cubed. Alright, so make sure you pull that x cubed to the bottom and make it positive. Right? This goes back to the rules of exponents that you should be familiar with. Alright, on number 3, same thing. We're going to try to find the derivative of this. So we say that y prime is equal to, again, we bring that 4 in front, so we have 4x. We subtract 1 from this power, so we have 4x cubed over 2, plus, again, 3 times 3 is 9, x squared, minus 2. All right, so one more time, 3 times 3 is 9, subtract 1 from here, and the derivative of negative 2x is just 2. All right, if we simplify this, just by dividing this out and just rewrite it, that would be your answer. Okay, so that's that. Now on the next one, all right, notice that we're looking to write the equation of the tangent line out of f of x is equal to 2x to the 4th plus 3 at x is equal to 2. So we want to know the equation of the tangent line. And if you remember, we said this several times, if I'm writing the equation of a tangent line, I need 2 things. I need the point, and by a point I mean an x and an y coordinate. All right, and I have the x coordinate, so to figure out my y coordinate where I have a tangent line, right, I have to plug in that 2 back into here. And when you plug in a 2 for x here, you would get 35. Right, so you can do that math if you like, but you're going to get 35 if you plug in a 2 here. And then the next thing I need to figure out is the slope. All right, so to figure out the slope, I need to take the derivative of this, because remember, the derivative can give you the slope. All right, so when I take the derivative, I'm going to use the power rule. So this is going to be, let's see, I'm going to multiply 4 times 2, which is an 8. x. And I'm going to subtract 1 from 4, so we got 8x cubed. All right? So that right here is the derivative function. If I want to figure out the slope of the tangent line to f of x at x is equal to 2, then all I have to do is plug in a 2 into the derivative function. All right? And that's going to give me 64. And again, one more time, this is the slope of the tangent line of f of x at x is equal to 2. Alright, so this is kind of a long sentence here, but I want to make sure you understand where this came from. Alright, so this is the slope of the tangent line of f of x at x is equal to 2. So finally, to write the equation of the line, I'm going to rewrite the formula for the point slope. And I'm just going to plug in everything I have. I have y minus the y coordinate that I found here. The slope is 64. And then I have x minus x1. So x minus the x that I started with, which is this one. And at that point, I'm done. That's the answer, right? This is the equation of the tangent line. Right, as I move on to the back. Oops, excuse me. I printed this in one page. Right, as I go to the back on this, right on the notes, okay, I have this right here. Right, so one more time, it says write the equation of the tangent line to the graph of the function. So it's exactly the same problem as last time. Alright, so I need to figure out the y coordinate first, or not first, but let's for the sake of finding the derivative, finding the slope, let's find the derivative, which is what we need for the slope, okay? Before I do that, I need to turn this into an exponential function. By that I mean, let's get rid of this radical and write this as an exponent. All right, so I would have 1/2 x to the 2/3, but that's going to be negative 2/3 because that's in the bottom. All right, so remember that the bottom, this root right here goes in the bottom, this power goes on top, and it's negative only because I brought it to the top. So therefore, if I'm taking the derivative, I can use the power rule. Right, on this one, I will have to write it. So I have 1/2 times negative 2/3, like that. All right, and I have to the power of x. Now remember, this would be x, and I have negative 2/3 minus 1, which will give me negative 5/3. All right, so negative 2/3 minus 1 is negative 5/3. Okay, so at that point I can simplify this further, and I want to have the f prime of x, the derivative of f of x, is equal to negative 1/3 x to the power of 5/3. Okay, now f prime of x, f prime of 8 is going to give me the slope, at x is equal to 8, all right, of the tangent line, that is. So this will be negative 1/96, and again, without a calculator, remember you take the cube root of 8, which is 2, and then you raise 2 to the 5th power, which is 32, and then you multiply it times 3. That's how we got this, all right? So don't forget, this is the slope of the tangent line of f of x at x is equal to 8. All right. All right, now we need to figure out our y coordinate. So one more time, we're going to plug 8 back into the original function to figure out the y coordinate. This is 1/8, all right? So on this one, you'll be glad to use the point slope formula, because if you're actually doing the the y equals mx plus b, this would be a little bit longer than this. So again, remember what I told you in the AP exam, you can leave your answer like this. Alright, so that's it. Alright, example 6. What's different about this? Alright, so if I'm going too fast, make sure to slow down, rewind, watch it again, do what you have to do. If I'm going too slow, then you feel free to fast forward me. Right, now this one says determine the points. Right, determine the points, if any, at which the function has a horizontal tangent. Alright, so remember that if we have a horizontal tangent, that means that the slope is 0, right? Remember, the slope is related to the derivative. So really what we're saying is that if the derivative is equal to 0, right? So that means that the derivative at that point, whatever that may be, is equal to 0. Don't forget, that's what that means, all right? So we're going to try to figure that out. So to do that, we first need to take the derivative. Now first, I'm actually going to simplify this. Let me write it up here. So I'm going to run out of room. I'm going to simplify this by dividing each one of these terms by x. Okay? So that's that. And then now the derivative would be equal to 4x minus 3. Now like we said before, this is what we're looking for. We're looking for the horizontal tangent, which means where is the derivative equal to 0? So I set the derivative equal to 0, and I solve for that. And when I solve for that, I get that x is equal to 3/4. Okay? Now here's the key. Now before they would say determine the x values where you have a horizontal tangent for the function of f of x, but this one says determine the point or points. Okay? Now when it's actually talking about determine the points, it's talking about an x and y coordinate. So when it talks about a point, it's talking about an x and y coordinate. Now I have my x coordinate. But to figure out my y coordinate, all right, remember this is the coordinate where you have a tangent line with the slope of 0. All right, so if this is the x, I have to plug this in back into this original one to figure out my y coordinate. So f of 3/4 is equal to 2 times 3/4 squared minus 3/4 plus 1. And then I'm just going to do some of the arithmetic here. That would be 9/16 minus 9/4 plus 1. And this would be an 8 here, so then I would have a 9/8 minus 9/4 plus 1. And then now I can add, if I want to add these together, I need to have a common denominator, so I'm going to multiply top and bottom here by 2. And I would have a 9/8 minus 18/8 plus 8/8. Alright, if I add all of these, I have 9 minus 18, which is negative 9, plus 8. That is going to give me a negative 1/8. Okay? So the point at which the function f of x has a horizontal tangent, well, that's the point 3/4, comma, negative 1/8. Alright, so at that point I have a horizontal tangent. So this is my answer. Alright, so I'm going to go ahead and move on to 25. Alright, so in the same lesson I'm going to move on to 25. So if you need to take a break, take it. And pause me for a minute and then come back, okay? So now on this one, let's say that on this one I'm asking you to take the derivative of this. So you can do this two ways. I mean, you can multiply this out. Alright, and I would have y is equal to x cubed plus x. And if I take the derivative of that, that would give us 3x squared plus 1. Alright, so don't forget that. Now again, if that doesn't make sense, go back to lesson 24 and or rewind this video and then watch the beginning of 24. Alright, so on method number 2, so maybe sometimes, alright, when you're seeing this, you might be thinking, well, if I have this function right here, maybe I can take the derivative of the first one. The derivative of x is 1. The derivative of x squared plus 1 is 2x. Okay, and then maybe I can get the derivative from that. But notice that this and this are not the same. So therefore, that doesn't work. Alright, so if you have two functions, do not take the derivative of each one and multiply them. But what you can do instead, you can use this product rule. So remember, this means the derivative with respect to x of f times g, where f and g are a function. Alright, so if you have two functions being multiplied together, and I'm asking you to take the derivative of them, you're going to have to use this formula. Right, this formula is important. It'll be here basically for the rest of the year. Okay, so to use this, that means the first, so you're going to write the function of the first times the derivative of the second function, plus the second function times the derivative of the first. Okay? Now, let's use an example so this hopefully will make sense. let's say that this is f and this is g. Notice that you have two separate functions that are being multiplied together. All right, so now I'm going to take the derivative. So I have h prime of x is equal to, now notice the formula, it says f. All right, so if this is f, I'm just going to rewrite it. All right, now this one says g prime, so I'm going to take the derivative of this. The derivative of this would be 2x. 2x plus 0. Okay? Plus g, which would be this, times the derivative of f, which is 2x plus 1. All right, so let's just make sure we're on the same page. This is f, this is g prime, this is g, and this is f prime. All right, so that's what that is. All right, so now that's actually the product rule. That's it for the product rule. Excuse me. Now all you have to do is multiply all of this and add all the like terms, which is normally the part that's not difficult, but just tedious. All right, so I'm going to distribute that 2x, so I have 2x cubed plus 2x squared plus 2x plus, I'm going to FOIL this now, so I have x squared times 2x, that will give me 2x cubed. X squared times 1 gives me x squared. Then I have 2 times 2x will give me 4x, and then 2 times 1 will give me 2. All right, let me check, make sure we're doing this right. We're good. All right, so now I'm going to add the like terms. All right, so that right here, I have a 2x cubed and another 2x cubed here. That's going to make that 4x cubed. And I have a 2x squared and an x squared is going to make that a 3x squared. And then I have a 2x and a 4x. That's going to make that a 6x. And then I have a, is that a 2? Yeah, that's a 2. It looks like a z. All right, plus 2 here. Okay. So that would be the answer, right? So this is the derivative of this right here. Now, could you multiply that together, distribute this out, and then take the derivative using the power rule? The answer is yes. All right. So always look to see what would be easier for you. On the next one, if I write it like this, I have x to the 1/2, and this would be 3x squared minus 1. All right. So on that, you really have a choice. If you want to distribute this x to the 1/2 to both of these, you could, and then use the power rule. But since we're talking, and I think honestly that would be easier. But since we're talking about the power rule, we're going to go ahead and do it with the power rule. Now don't forget, one side note is, remember, when I multiply this times, if I were to multiply this times this, right, I would add the exponents. So don't forget that if I were to multiply this 2 out, I would add the exponents. Okay. So now let's do the product rule once again. So we have y prime is equal to the first, which is x to the 1/2, times the derivative of this, which is 6x, plus 3x squared minus 1 times the derivative of x to the 1/2. Now the derivative of x to the 1/2, don't forget, I'm just going to bring the 1/2 in front. I'm going to rewrite that x. And I'm going to subtract, on the exponents, I'm going to subtract 1 from 1/2. So 1/2 minus 1 is negative 1/2. All right, so we have 1/2 to the power of x to the negative 1/2. All right, now that's it for the product rule. Now the rest of this is algebra. So I'm going to multiply that times that. That is going to make it 6x. And then x to the 1/2 times x to the first power, I would add 1/2 and 1, which makes it 1.5. Or 3/2. And this one, same thing. If I multiply 1/2 x to the negative 1/2 power times this, I would get 3/2 x, and then 2 plus a negative 1/2 is 3/2 minus, let's see, what should we have after that? Minus 1/2, and I'm going to go ahead and leave this x to the 1/2 down here. Now I'm going to go ahead and transfer that. Now I'm going to add like terms. Notice that if I can rewrite this as 12 over 2. So without me, well, let me write it. All right, and then now I can add like terms, and I would end up with 15 over 2. x to the 3 halves minus 1 over 2x to the 1 half. Alright, so this would be the answer. You could find a common denominator if you wanted to, but at this point I'm not. Check out the answers. I sent the answers in a reminder on Twitter. If you want to take a look at that, check your answers to see if I got what you got. Sometimes you may be doing more work than you need to. Okay? Moving on. Now, on the back of 25, all right, we're going to use something called the quotient rule. Now, the quotient rule is only used if you're taking the derivative of a function divided by another function. So every time you have a function divided by another function, and I'm asking you to take the derivative of that, you're going to have to use that formula. All right, so now this one's harder to remember. All right, notice that you have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. Now, the way that some people remember it, a lot of calculus teachers use this trick where they call this the high and they call this the low. Okay, I don't know if it's a low. So basically what they do is they say low d high. When they say d high, they mean the derivative of the high one, which is this one. So low d high minus high d low. High d low, the derivative of the low. All right, so low d high minus high d low over the bottom square. Okay, so hopefully that helps you remember it, but you're going to have to memorize it either way. And this is one of those things that's really not going to go away. All right, so let's go ahead and take the derivative. It says find dy dx. Remember that just means the derivative. So dy dx is equal to, now we're going to use this. All right, so we have, if this is, remember this is f and this would be g. All right, so we have low d high, so we have low d high, which is the derivative of this, which would be 2x plus 1, minus the high, which is this part, d low, which is this part, over the bottom square, like that. All right. Now, that's it for the formula, but again, I have to FOIL this. Oh, hold on just a second, I messed up here. I just realized that I did not take the derivative. Oh, sorry. All right, I did not take the derivative of this. I'm sorry. So this is times the derivative of this one. The derivative of that one would be 3x squared, like that. All right, so it would be 3x squared, and this is up parentheses. All right, so now it's looking a lot better. So we're going to have to FOIL this, distribute that, add the like terms. All right, so we have dy dx is equal to, FOIL this, so we have x cubed times 2x, we'll make that a 2x to the 4th. X cubed times 1, we'll make that an x cubed. All right, then we have 6 times 2x, 12x, and then 6 times 1, which is 6. Now, the place where people are going to screw up is here. All right, so make sure that I would honestly leave that negative right there, and I would write the next, whatever, when you distribute this, write it inside this bracket or parentheses. So we got 3x squared times x squared, 3x squared times x, 3x squared times a negative 2, over this square, over the bottom square. Alright, so don't try to FOIL that or anything like that, leave that alone. Alright, now for the sake of time, right, I'm not going to rewrite all this, but remember that this negative is going to make these the opposite sign. Alright, so now I'm going to add like terms. 2x to the 4th minus 3x squared will give me a negative x to the 4th. 2x to the 4th minus 3x to the 4th will give me negative x to the 4th. X cubed, now remember that's going to be a minus 3x cubed. X cubed minus 3x cubed will give me negative 2x cubed. And then now I don't have any squares here, but I do have one here. That's going to be a positive 6x squared. And then I have whatever's left, 12x plus 6 over x cubed plus 6. Now the next one, I hope that if you're listening to this on video, to pause this for a minute and to figure out what is it trying to ask me. Okay, once you have done that, okay, if you don't know where to go, it says determine if h of x, that's really what it's asking us. Determine if h of x is increasing, decreasing, or constant. Now, if I want to know that, that's related to the derivative. How? How is it related to the derivative? Well, if you remember, if the derivative, and by that I mean if h prime of x is positive at x is equal to 3, then that means that h of x is increasing. All right? If the derivative at x is equal to 3 is negative, then it's decreasing. And if the derivative is 0, then that means that the function at that point is constant. Okay. So what we're gonna do here, since we don't have any functions, but we do know that h of x is f of x times g of x, which is two functions being multiplied. So we're gonna follow this product rule. All right. So the product rule, which I don't have here, the product rule, which looks like this, your formula is going to look basically like this. It's exactly the same. All right, so this right here would be f of x, the first times the derivative of the second. And now, since we don't know what g of x is, that's fine. We're just going to call that g prime of x. All right, plus g of x times the derivative of f of x, which is f prime of x. Now what we're trying to find out is, what is the derivative at 3. All right, so if I do that, actually all I need to do is plug in at 3 for every x that I see here. All right, now, but I do know what f of 3 is. F of 3 is 5. And then g prime of 3 is 1. And then g of 3 is, where is it? It's 6. And then f prime of 3 is negative 2. All right, so h prime of 3, if you multiply that times that and then subtract that, would be negative 7. All right, and because the derivative at the derivative at x is equal to 3 is negative. Therefore, because this is negative, therefore, h of x is decreasing at x is equal to 3 because h prime of 3 is negative. And I'm just going to say negative like that, okay? Now, because I do not like making a lesson very long, I'm going to go ahead and stop here. However, on the next part it says, then determine the same for this. Now, notice that you're dividing, so you would have to do the same thing, but instead of that, you would have to use, the quotient rule, and then that would give you to that answer, which is the same thing. All right, so if you got any questions, make sure and ask. Check out the solutions on Twitter. And if you got any questions, well, ask me tomorrow. We're going to be working on this tomorrow.